Welcome to the Bodhi Academy. My name is Humjan, and in today's video we will continue with our chapter Human Eye and Colorful World. So in today's video we will talk about some important terms like refraction of light through a prism, then dispersion of white light by a glass prism, then what is a rainbow and why does it occur, atmospheric refraction, then try to answer some of the questions like why does the stars twinkle, why do planets don't twinkle, advanced sunrise and delayed sunsets. Then we'll also learn about a Tyndall effect and we'll answer the question why the color of the sky is clear blue. So to begin with, let's understand what is refraction of light through a prism. So now when a ray of light is incident on a rectangular glass slab, after refracting through the glass slab, it gets displaced laterally. As a result, the emergent ray comes out parallel to the incident ray. So here what is happening is that, see, this is the glass prism that we have A, B, C, and there is a incident light or an incident ray that is going through. So say that incident ray is this PE. Okay, then it is, what is happening here is that a PE which is there, it is getting refracted in the direction of the normal itself, and that is the EF, and then it gets diverted as FS. So you may have noted that a ray of light is entering from the air. So here this outer medium is the air that we have, and then this AB, that is a new surface, that is a glass surface. So in that case we have two mediums through which the light is passing. So first is the air and second is this glass prism. So the light ray on reflection has bent towards the normal. So here this incident ray which is there PE, it then bends towards the normal. The normal is in this direction. So this EF, it is bending towards the normal. At the second surface AC, the light ray has entered from glass to air. So now first it entered from air to glass and then the ray bent towards the normal. Now again it is going to enter from glass to the air. So there, that is the AC surface. Hence it has bent towards it has bent away from the normal. So if the normal is here, then this ray, see here, it is bending away from the normal. Compare the angle of incidence and the angle of refraction of each refracting surface of the prism. So the peculiar shape of the prism makes the emergent ray bend at an angle to the direction of the incident ray, and this angle, it is called as the angle of deviation. So in this case you will see, if you extend these lines, then you get the angle of deviation, that is the D. Angle A is the angle of the prism. Even angle A, B and C are the angles of the prism. Then angle I is the I over here, that is the angle of caused by incident ray. So it is the angle of incident. Then we have angle R which is there, that is the angle of refraction. Then we have the angle E, that is the angle of emergence, and angle D, that is, on extending all of these we get the angle D, that is the angle of deviation. Now we'll understand the dispersion of white light by a glass prism. So what we see here is that this is the prism PQR, okay, and this is the beam of white light that is entering. What we see here is that the white light is getting broken down into its constituent colors, that is the 7 colors: red, orange, yellow, green, blue, indigo and violet. Out of these, the least deviated or the least bent one is the red, and the maximum deviation or most bent is the violet. So a prism, it has two triangular bases and 3 angle of prism, it is the angle between the two lateral faces, and angle of deviation, it is the angle between the incident deviation. Dispersion of white light by a glass prism. So the phenomena of splitting of white light into its 7 constituent colors when it passes through a glass prism is called as dispersion of white light. That is what we saw in this diagram. So white light is passing and then it is getting dispersed into its constituent 7 colors. The various colors seen are violet, indigo, blue, green, yellow, orange and red. The sequence of color remembers as Vibgyor. So this sequence is remembered as Vibgyor. So we have violet, indigo, blue, green, yellow, orange and red. The band of 7 colors is called a spectrum. So this band of all these 7 colors together, it is called as the spectrum. The different component color of light bends at different angles with respect to the incident angle. So if you see here, not all the colors that are formed here, they are not bending at the same angle. If you see, the red one has the least bending that is occurring. Then the bending increases as we move from red to violet, the bending has increased. So they are bending at different angles with respect to the incident angle. The violet light bends the least while the red bends the most. Recombination of white light. So Newton found that when an inverted prism is placed in path of dispersed light, then after passing through the prism, they recombine to form a white light. Now this is a erected prism. Okay. Now if I place a inverted prism right next to it and the white light is passing, then it is getting bent into all the different colors, and then what will happen, these colors will pass through another prism that is there, which is in the inverted form. So in that case, what will happen, see here, like this, in this form, then what will happen here is that we will get back the white light, and this was first discovered by Newton. Isaac Newton, he was the first who obtained spectrum of sunlight by using a glass prism. He tried to split the spectrum of white light more by using another similar prism, but he could not get any more colors. So what he thought, that maybe on splitting of sunlight, what he saw, that there was some kind of spectrum that was formed. So he tried using another similar prism, but expecting that he would get even more colors, but that was not the case. He was getting the same number of colors. He repeated the experiment using second prism in inverted position with respect to the first prism. It allowed all the colors of spectrum to pass through the second prism. He found white light emerges on the other side of the second prism. So when he was doing this experiment, what he did, he tried a inverted prism. So what happened in that case, that all the colors of the spectrum which were there, they passed through the second inverted prism and we got back the white light. Now let's look at what is a rainbow. So it is a spectrum of sunlight in nature. So it is based on a similar concept of dispersion of light. So it is formed due to dispersion of sunlight by tiny water droplets. So now when we were speaking about dispersion of light, we took an example of a glass prism. Here now that glass prism, instead of glass prism, we are having the water droplets that are there, which act as the medium for dispersion, and they are present in the atmosphere. Now formation of this rainbow. So the water droplets act like small prism. So each water droplet which is there, it acts like a small prism. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the drop. So if you look here, see, this is the sun and this is the water droplet that is there. So what is happening, the incident ray is getting refracted first, then what is happening, it is getting, you see here, it is getting reflected internally. Okay, it is not coming out till here, it is not passing out from here, it is getting reflected back internally and then it is getting refracted. So and finally it gets refracted again when it comes out of the drop. Due to dispersion of light and internal reflection, different colors reach the observer's eye. So this is how we can see the rainbow. So the red color appears on top and the violet at the bottom of the rainbow. A rainbow is always formed in the direction opposite to that of the sun. So now at point A, what is happening? There is refraction. Point B, there is reflection, and if you look at point C, there is both refraction and dispersion that is taking place. Now let's talk about atmospheric refraction. So now in atmospheric refraction, The first example that we have is the twinkling of a star. So the twinkling of a star is due to the atmospheric refraction of starlight. So the starlight on entering the Earth's atmosphere undergoes refraction. So when the light from the star, what happens? It is entering the surface of the Earth or the atmosphere of the Earth. In that case, it begins to undergo refraction. Why? Because we have n number of mediums that are present in the atmosphere, and it continues to do so till it reaches the Earth. So the atmospheric refraction occurs in a medium of gradually changing refractive index. So there are various, till it reaches Earth, there are various mediums that are present, and therefore it keeps on the atmospheric refraction that is there, it occurs in a medium gradually changing the refractive index. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from its actual position. So when we look at any star, what is happening, that due to this bending that is happening towards the normal, we can look at an object slightly different from its actual position. So the star appears slightly higher than its actual position when viewed near the horizon. Further, this apparent position of the star is not stationary but keeps on changing slightly, since the physical conditions of the Earth's atmosphere are not stationary. Therefore, what is happening here is that there is a movement in this stars that is happening, and that is why, because of a non-stationary system of the Earth's atmosphere, as was the case in the previous paragraph. Since the stars are very distant, they approximate point-sized source of light. As path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering the eye starts to flicker. The star sometimes appears brighter and at times it appears fainter, and this is the twinkling effect of the stars. Now, if we are saying that stars are blinking, in that case we even call planets as stars. So why don't the planets blink? So with respect to planets, what is happening is that the planets are much closer to the Earth. The stars are way more farther than the planets. So planets are much closer to the Earth, and thus they are seen as the extended sources. So if we consider these a planet as a collection of large number of point-sized sources of light, so therefore the total variation in the amount of light entering our eye will go to null. So therefore it will go to 0. Therefore we cannot see the planets twinkle. Next we have advanced sunrise and delayed sunset. So it is known that the sun is visible to us 2 minutes before the actual sunrise and 2 minutes after the actual sunset, and this is also because of atmospheric refraction. By actual sunrise, we mean that the actual crossing of the horizon of the sun shows the actual and apparent position of the sun with respect to the so here we have the observer, and here we have the apparent position of the sun, and here is the horizon. So in this case, what is happening is that at this point we see here, this is the actual position of the sun, whereas we see it at this point. So that is the difference that is happening here. That is a lag of 2 minutes that is happening. So the time difference between the actual sunset and the apparent sunset is about 2 minutes. The apparent flattening of the sun's disk at the sunrise and sunset is due to the same phenomenon. Next we have the scattering of light. Now under scattering of light we have two major effects. One is the Tyndall effect, and second we'll talk about why the color of the sky is blue. So when a beam of light strikes the minute minute particles of Earth's atmosphere, suspended particles of dust and molecules of air, the path of beam becomes visible. So this phenomena of scattering of light by colloidal particles gives rise to this Tyndall effect. So now if you have seen, if the roof has a small opening, in that case what happens, you see a beam of light that is entering. In that, what we see is that you see suspended dust particles, okay, and this phenomena of scattering of light by this colloidal particles which is there. This is known as the Tyndall effect. It is observed when sunlight passes through a canopy of dense forest. Same thing in forest, if there is like very huge number of trees which are very dense, then through them also the small rays of sunlight which enter, in that also you could see this colloidal particles which are present that are dispersed. The color of the scattered light depends on the size of the scattering particle. Last, why is the color of the clear sky blue? So the molecules of air and other fine particles in the atmosphere, they have smaller size than the wavelengths of the visible light. So wavelength of the visible light is what? Quite higher as compared to the fine particles that are present in the atmosphere. These are more effective in scattering light of shorter wavelengths at the blue end than light of longer wavelengths at the red end. Therefore, there is more scattering where happening to the light with the shorter wavelength at the bluer end as compared to the longer wavelengths at the red end. The red light has a wavelength about 1.8 times greater than that of the blue light. Thus, when the sunlight passes through the atmosphere, the fine particles in air scatter the blue color more strongly than that of the red. So here, because of this phenomena, because the wavelength of red is so greater, therefore what is happening, this red light is not being scattered, whereas we see the scattering of air happens in the blue color. The scattered blue light enters our eyes. If the earth had no atmosphere, there would not have been any scattering. So because the earth has atmosphere, because it has this various mediums that are present, there is this scattering that is occurring. If there was no atmosphere, no such scattering would occur, and we would have a sky which would appear very dark. The sky appears dark to passengers flying at very high altitudes, as scattering is not prominent at such height. So if you are traveling or flying at altitudes, in that case what will happen, we cannot see this scattering, and therefore we see darker region over there because of the absence of scattering. So this was it for this chapter. Please don't forget to like, share and subscribe to the Bodhi Academy.